called Mad Science. But what is this station?
Oh, it's a mom. Oh, it's a molecule.
Yes, molecules. We're going to talk about molecules. Okay. So, does anybody know what a molecule is?
It's like a little marble inside of like a liquid, a gas, or a solid.
Okay, those are the three states. That's right. So it's not really like a marble. It's close, but you'll learn the more specific things. For now, we could say they're kind of like little marbles, and they're so tiny you can't see them. And they're made of things called atoms. Atoms are the individual elements. You guys have seen the periodic table before?
Yeah.
Raise your hand if you saw the periodic table. Okay. If you break everything down into the finest, smallest ingredients in the world, this is what you come up with. So I'll give you an example. If you're going to make a cake, you need individual ingredients like sugar, flour, water, right? Those are the main things in a cake. So if you take everything in the world and break it down into the smallest pieces, you get hydrogen, oxygen, iron, let's see what are some else you know, gold. All those things are specific single elements, they're called, and they're atoms. And if you put them together, you can make molecules, and you can combine them in so many different ways that you can make an almost infinite number of molecules. You guys know what infinite means?
Keeps on going.
Keeps going forever. That's right. You can make so many. And everything you ever saw or heard or smelled is made of molecules. Everything in the world is made of molecules. There's so many of them. The largest one in the world, or in nature, is called DNA. That's something that's in every one of your cells. It's the largest molecule that exists. It's made up of these tiny atoms, so many millions of atoms that if you stretch, even though you can't see it, it's microscopic, if you were to stretch it all the way out, it would be this tall, from the floor to my head. Okay? But you have billions of them inside your body. That's how small they are, how skinny. And the smallest one is hydrogen, which is in the air right now. Rolling around. It's the smallest one. It's right here. This is the air. Okay? So we're going to talk about the different states. So all matter is made up of molecules, and it exists in different states. There's solid, liquid, gas, and one more thing.
DNA.
No, that's a molecule. It's called, what's lightning made of? What's lightning made of? What? Thunder? No. Yes. It gives off light. Light's not a, it's called plasma. It's called plasma. Okay. The main forms, though, are solid, liquid, and gas. So we're going to talk about the solid to liquid. What's that called? It's a very scientific name for it. If I held ice cube in my hand and it's turning to water, what are you doing? That's it is
technically right.
What's increasing? That's very good. But that's a big answer. So, melting. That's right. Very technical answer. Okay, and if you take water now and you get it into the air, turn it into a gas, what is that called? I'm calling you evaporation. Very good. Now let's go the other way. We have a gas and we put it down into a liquid. What is that called? We change it to a liquid.
Condensation.
Condensation. Very good. Very good. Now we take the water that's condensed and we turn it back to ice. What are we doing? Freezing. Very good. Okay. Now, but there's one particular material that, so water goes from ice to water to gas to water vapor, right? It goes through those stages. There's one that goes from ice form right to gas, and that's called sublimation. If it skips the liquid altogether, and I'm going to show you an example of that. My glove on. Okay, this is frozen carbon dioxide. Anybody know what that's called?
It's what your body produces.
Produces what?
It's what your body produces to
To trees?
Yeah, he's
We produce frozen carbon dioxide?
It's dry ice.
Okay, somebody said it out loud, but I'm going to call on whoever raised their hand. Dry ice, very good, very good. Now, see what's happening as I'm holding it? If I hold it too long, it's going to freeze my hand solid. So I can't hold it very long. That's why I'm wearing gloves. It's super, super cold, much colder than regular ice. Okay?
Dry ice can actually touch you with your finger.
It stings because it's so cold it freezes like frostbite. Okay, so that's why I'm jiggling it around here so it doesn't. But if I take this ice, yeah, and I didn't get prepared with the water. What? I just need any water. Let's put a little bit of this in. Just put a little water in here, and then I'm going to drop this block of dry ice in there. And what you're seeing is that water is helping that ice to melt faster than my hand was. And so it's making, basically, steam. Okay? But it's carbon dioxide gas that's forming. So it's going right from liquid right to gas. And notice that the carbon dioxide is heavier than the air, so I can actually pour that gas out.
What?
You see that?
It's called steam.
It's like steam. Okay, so we talked about the 3 states, and I'm going to show you something. So solids, what happens if you take a solid and you have it in a cup and you pour it? How come you have your hand up before I ask the question? No, go ahead. You have a question? Go ahead.
No.
Okay. You have a question? Or answer?
The solid has a definite shape, so it won't fully contain.
Right. Well, it feels right. So what's going to happen when I pour it out?
It's probably going to stick or it's going to fall.
Well, it's fall, but what's it going to do?
It's going to keep it shape.
It's going to keep its shape. So I pour it out and it keeps its shape. That's right. Now what do I have to apply to it to make it change its shape for a solid? I'm going to call somebody force. Very good. If I put force, it's going to change the shape. If I have a liquid though, I don't have to put a force to change the shape. I can pour a liquid out. So right here, I poured this water into this cup, right? I pour the water in, and the water takes the shape of the cup, right? I can change the shape of this water to anything I want by putting it in a container of that shape, right? If I had, so what's your name? Kate? If I had a cup that was shaped like Kate, I can make Kate-shaped water, right?
Oh, that's silly.
So liquid takes the shape of the container. It also pours out, and so here, imagine these are water molecules. I pour them. And as long as I don't spill them, they go into the container and they take the shape of the container. But now you saw I poured this gas, right? I poured this gas. I pour a gas like that. Let's see what's happening to those molecules as I'm pouring the molecule of gas. They're going everywhere.